Hello once again. In the previous video on chapter 8 from the Edexcel Core 2 book, we've looked at sine, cos and tan and how you work out the sine, cos and tan values of angles that aren't 90 degrees or below. Alright, now you've been able to figure out sine, cos and tan values of angles from 0 to 90 degrees in your GCSE and also in your previous chapters from Core 2. Alright, but in the previous video that I put out, you were able to figure out angles that aren't necessarily between 0 to 90, the sine, cos, tan values of angles that aren't necessarily between 0 to 90. Alright, now in this video I'll show you the graphs of sine, cos and tan. Alright, so the equation of the graphs would be y is equal to sine x, or y is equal to cos x, and tan is y is equal to tan x. Alright, now many students I know basically memorize these graphs. They just say, let me change the color. They'll just do this. Oh, this is a sine graph, and this is the cos graph, and this is the tan graph. It's gone slightly askew, but never mind. Okay, alright, now they just memorize the graphs, and they'll just memorize the key intervals in this graph, which will be 0, 90, 180, 270 and 360. And like I said, there are few students who have teachers who don't teach the quadrant rule to work out angles, sine and cos tan values of angles that aren't between 0 to 90. Okay, you really need to know the quadrant rule to work out the sine, cos and tan values of angles which are above 90. Alright, relying on the graph alone is not advantageous, it's not useful. Alright, so the teachers have just basically made them memorize the graph, and you know, from that they work out the cos, sine, tan ratios of angles above 90 degrees. Okay, now I'm going to show you how you would use the quadrant rule to figure out the cos, sine, tan values of angles from 90 and above, and then from that, using those results, we are going to sketch the graph. Okay, so I just don't want you to, you know, memorize these shapes and say, okay, now I've learnt it. Alright, I really want you to know how to derive these graphs by working out the individual points. Okay, so let's start off with the sine graph. So y is equal to sine x. Alright, so let me just go up in well, let me choose angles that are useful. Okay, 30, 45 and 60 and 90. Okay, so if I make that my x coordinate, my y coordinate would be sine of that value. So sine 0 is 0, sine 30 is half, sine 45 is 1 over square root of 2, sine 60 is square root of 3 by 2, sine 90 is 1. Alright, so that you probably wouldn't have any problem because you can get those values of the calculator. Alright, now let's move on to sine of 120. Alright, now we've got to rely on our quadrant rules now. Sine of 120. Alright, okay, so 120 will be an angle in the second quadrant, and in the second quadrant sine is positive. Alright, sine is positive, and the angle that it makes with the horizontal would be 60 degrees. So 60 is the equivalent angle in the first quadrant. Okay, but because sine is positive in this quadrant, it will be the same value as sine 60. Alright, so because sine 120 is same as sine 60, because the angle that it made with the horizontal is 60 degrees, so that would be sine 60 as well. But because sine is positive in this quadrant, it will be positive. So whatever result sine 60 had, that would be the same for sine 120. So sine 60 was root 3 by 2, which is approximately 0.86. Alright, so let's move on to sine 135. Again, if you draw 135. It looks like this, and the angle that it makes with the horizontal is 45 degrees. So therefore it will be sine 135 will be same as sine 45, and whatever result you had for 45, that will be the same for 135. And next we look at 150, sine of 150. Again, it's like this, and the angle that it makes with the horizontal is 30 degrees. So sine 150 will be equal to sine of 30. Alright, so that is half, and then sine 180, if you follow the same method, you'll get 0. Alright, so we figured out what it is from 0 to 180. Okay, now let's see what happens when I try to figure out the sine value of an angle like 210. Alright, 210. Okay, now let's do the same thing. Let's do the quadrant rule to figure out the equivalent angle in the first quadrant, and then figure out what that sine value of the first quadrant. Okay, and then that will be equivalent to the ratio, the sine value of that angle there, 210. Alright, so if I draw 210, it'll fall here in the third quadrant, so that'll be 180. So the rest there is 30 degrees. Alright, so it's 30 degrees. That's the angle that it makes with the horizontal. So that's equivalent to 30 degrees in the first quadrant. So sine 30 is equal to sine 210. Correct? Not quite, because we know that if you look at the rules to do with the quadrants, if you have an angle in the second quadrant, and if you were to try to make make an equivalent angle to that angle in the first quadrant, it would be the same ratio and would be the same sine if it's for the sine function. Okay, but if you were to find the cos and the tan function for the angle that fell inside this quadrant, it would be the negative value of what you had in this quadrant. Okay, and in this quadrant though, it's only tan that is positive. So here we are actually trying to figure out sine. So this 30 degrees that would be in the first quadrant is not similar. It wouldn't have the same sine ratio for sine 210. It would have the negative value of that ratio that you had in the first quadrant to that angle. Okay, in the third quadrant. So sine 30 is actually negative sine 210, or you could say sine 210 is equal to negative sine 30, as long as there's a negative on one side. So sine 210 is actually sine 30 but negative. What is sine 30? It's half, so it's negative half, or negative 0.5. Alright, so let's pick another angle. How about an angle in the fourth quadrant? 315. Let's draw that once more. Here in the fourth quadrant, and the angle that it makes with the horizontal there is 45 degrees. So sine 45 should be equal to, again, negative sine 315, because in the fourth quadrant it's only the cos that is positive. So sine and tan will be negative in the fourth quadrant. So we're figuring out sine here. So that answer there will be sine 315 will be equal to a negative 0.71, which is approximately the answer for sine 45. So that would be negative 0.71, or you could say 1 over square root of 2, as I have set on top here. Alright, for 45 degrees. Okay, right. Okay, now what I have here is a table showing you all the sine values of angles from 0 to 360. Alright, it just didn't look neat enough here on this table, so I've just gone into one of my spreadsheet programs and got this table up for you. Alright, now using this, let's sketch our graph. Alright, so let me draw a pair of axes. Okay, now let's just give me a moment, please. Okay, let's start plotting the points. So at 0, the sine value is 0, and at 30, it's 0.5. At 45, it's 0.71 approximately, and at 60 is 0.86 approximately. Should be 87 really, never mind. At 90 it's 1. At 120 it's same as 60. 135 same as 45. At 150 same as 30. At 180 it's 0. So let's plot whatever we have here. Let me choose a different color now. Okay, I can see the sinusoidal shape appearing. Alright, now that's what I showed you right at the beginning. I showed you that's what the sine graph's about. Okay, and you can see now that shape sort of appearing, alright, on our sketch. And that's because these values give these values of sine, alright. Okay, now it's not by magic that you have a shape like this. Okay, lots of students don't quite understand why you get a shape like this. It's because these angles give these sine values. Alright, now let me sketch the rest of the graph. So at 210 it's negative 0.5. At 210, sorry, 210. At 225 it's 0.7. At 240 0.86, and at 270 it's negative 1. Okay, so let me show you how that sketch would look. Okay, so I plotted the rest of the points for you, and you're getting a sinusoidal shape. Alright, good. Now let's do the same for the cos graph. Okay, we're going to try and figure out the cos graph. Again, you got to do the same. You got to work out the cos values for angles between 0 to 360, and just working out the cos values of some key angles. Cos 0 is 1, cos 30 is 0.86, cos 45 is 0.71, and cos 60 is half, and cos 0 is, I beg your pardon, cos 90 is 0. Alright, again we've got to work out the cos value of 120. Do the quadrant rule. 120 falls inside the second quadrant, so this angle here will be 60. So cos 60 will be same as cos 120, but again in the second quadrant cos values aren't positive, they're negative. So minus cos 60 is equal to cos 120. So therefore cos 120 would be equal to a half. Alright, cos 120 would be equal to a negative half. Okay, here again I have a few angles here between 0 to 360 and their cos values. Oops, that says sine, but these are actually the cos values. Okay, so these are actually the cos values of these angles. Alright, so if I were to sketch it, the graph would look something like this. Okay, now I didn't spend much time like the sine graph plotting individual points. It should roughly tally up. Okay, so the graph would look something like this. Okay, so far you've learned about the cos graph and the sine graph. So in the next video I'll show you how you work out the transformations for these graphs, and also we've not looked at the tan graph. Slightly different tan graph is, so we'll look at that in the next video. Thank you, bye bye.